Welcome to the night class. Today we're doing 5-3. We really should get that as my intro. Let's get it started. I think it's already copyrighted. There we go. All right. So the unit circle is what we're doing today. I'll be honest, okay? These are written down on your notes there. I would not waste time memorizing these, okay? There's another one that's very similar that you are going to memorize, but the one that you're going to memorize works all the time. These only work on the unit circle. And you're like, what is the unit circle? The unit circle is a circle on the coordinate plane that has the center is the origin, and its radius equals what? 1. Okay? So that is what's considered to be the unit circle. All right? What is that point right there? 1 what?
0.
1, 0. What's this point? What's this point?
1, 0.
And what's this point? 0, -1. Okay, so you have all 4 points, and they all represent a different angle. Okay, so this is 0 degrees, right? Up here is 90 degrees, 180 degrees, 270 degrees way down there, all the way back up to 360 degrees. Okay? And so basically, this is just giving you a shortcut of how to solve these specific 4 angles, but it also can find any angle. But usually you only have to have them for these 4 or 5. Okay? The reason you don't need them for the others.
Teachers, at this time, anybody that spits the last name H through L, please go to the gym for pictures.
Let's say we were talking about 45 degrees right there. Okay? And you wanted to find the sine, cosine, tangent. Okay? So we just talked about that yesterday. What can I make out of this?
Right triangle.
A right triangle. Okay? Remember how we always make a triangle with the x-axis for all our angles? Okay, you can do it for any of them. All right? Well, the problem with that is you can't do it. Oops. If I said 90 degrees, okay? There's 90 degrees. I'm supposed to make a triangle with it by just going straight down to the x-axis. Well, if I go straight down to the x-axis, I just have a line. I don't have a triangle. Is that making sense? Okay. Now, if it's off just a little bit, now I can make a triangle. Okay? Going straight down to the x-axis like I'm supposed to. So you can't do that at 0, 90, 180, and 270. You can't make a triangle with the x-axis. Okay, that's the key, because remember, we're talking about our reference angles. You always, talked about our bow tie. Y'all remember? Okay, y'all remember talking about that? Okay, so you can't do that when you're talking about these 4 specific angles. So it makes it very simple. All we're going to do is follow along these guidelines. It says if I wanted the sine of 180 degrees, well, what's it say sine equals to? Y. I come over here. Here's my point for 180. There's x. There's y. So what's the sine of 180 degrees? 0. Okay? If I said the tangent of 270, well, it says tangent's what? Y over x. Okay, that's a dividing sign, by the way. I couldn't. All right, y divided by x. Well, here's 270. X is 0, y is -1, so that would be what? Over what? Negative 1 over 0. That's undefined because you can't divide by 0. Does everybody see what we're doing there? Okay? If I wanted, say, tricky, the cosine of negative 270 degrees. That looks like cosine minus. So cosine of negative 270 degrees. That means I go which direction? Clockwise, right? So negative 270 degrees is this way. So what point am I going to use? The one that's at 90. Okay? So cosine's equal to what? X. So what's my x? 0. Very little work to do. You just got to make sure you understand. Sine is equal to y. Cosine is equal to x. Tangent's y over x. Okay? This will also go when we get to do identities. If tangent equals y over x, and sine is y and cosine is x, you can say tangent equals sine over cosine. Okay? But that's for another day.
Mr. Knight,
Yes, ma'am.
please send Allison Eagle to the library for a moment.
She's absent today.
All right, thank you.
You're welcome. All right, so let's scroll down and let's do some examples real quick. I have a unit circle there for you. Should everybody see that? It's on the back. So tangent of 180. Here is 180 degrees. What point would that be? Negative 1 and 0. Okay? And so tangent was what over what? Y over x. So what's y?
0.
0 over x. Negative 1. So my answer is 0. Okay? Secant of negative 90. Where is negative 90 degrees at? At the bottom. So what's its point? 0, negative 1. Make sure if you name it wrong, you're going to get them wrong, okay? So secant is the reciprocal of what? Cosine. So cosine was x, so that means secant must be 1 over x, which is, what's x? 0. 1 over 0 is undefined. Everybody good? Easy enough? That's pretty much all it is. Now understand, this works for any random point. Okay, so if, say we had here, okay, and I know you're not going to believe me, but that would be square root of 2 over 2 and square root of 2 over 2. Okay? What angle did I just do?
45.
That's a 45-degree angle as best I can draw it. Okay? And here's why all this works. Okay? 45, right? This is 1. My radius is 1, right? Because it's a unit circle. So to get the leg, I'm going to divide 1 by the square root of 2. Because remember, the leg times the square root of 2 is the hypotenuse. So if you're going the other direction, 1 divided by square root of 2, well, that will equal to square root of 2 over 2. So how far do I go right? Square root of 2 over 2. How far do I go up? Square root of 2 over 2. So this point is square root of 2 over 2, comma, square root of 2 over 2. And now if I wanted to, I could do the sine, cosine like I was. Okay, sine was the y. So the sine of 45 is square root of 2 over 2. The cosine of 45 is also square root of 2 over 2. Tangent of 45 is 1, because you have square root of 2 over 2 divided by square root of 2 over 2. Okay? So it does work for other angles. You just need it for those that are on the axes. Is that making sense? Okay? And we'll do it using them. Now, does SOHCAHTOA still work? Yeah, it still works. Okay? Absolutely. Opposite over hypotenuse, adjacent over hypotenuse, all that still works. All right? So don't think you're throwing SOHCAHTOA out the door. You can still use it. It's just sometimes easier to use the unit circle. All right? So let's do something like this. 30 degrees says use the unit circle to find the values of the 6 trig functions. So 30 degrees, I'm going to do my best to draw it. It would be about right there. Okay. $30 degrees. What's my radius? 1. And by the way, if you haven't noticed yet, your radius is basically always the what of your triangle? It's always the hypotenuse. Okay? So I'll be honest, that's probably a little more than 30 degrees, but I want you to be able to see it good. Okay? All right? So if my hypotenuse is 1, everything revolves around what on 30, 60, 90 triangles? The short leg. So what's my short leg if the hypotenuse is 1? It's a half. Because, right, the hypotenuse is twice as big as the short leg, correct? So if the hypotenuse is 1, my short leg is 1/2, what's my long leg going to be? The short leg times what? Square root of 3. So that would be the square root of 3 over 2. And now I can find my point right here. Okay? What is that point? How far do I go right? Square root of 3 over 2. How far do I go up? 1/2. Now I have my x and my y. And now I can do all 6. Okay? So sine of 30 is equal to y. And what is y? 1/2. And if you look at your chart that we filled out yesterday, you'll see that sine of 30 is in fact 1/2. Ooh, you're cheap. Oh, it's in physics. Oh, yeah, y'all do use this, don't you? So the cosine of 30, cosine is equal to what in the unit circle? Not y, but what? X. So, what's x? Square root of 3 over 2. Tangent of 30. Well, tangent's y over x. So what's y? 1/2. Divided by what's x? Square root of 3 over 2. How do I solve that? What do I do? Flip it and multiply by the reciprocal, right? So 2 over square root of 3. The 2's will cancel. I'll leave left with 1 over the square root of 3. Can you leave it like that? Nope. Move your square root of 3 to the top. Take the square root off the bottom. Square root of 3 over 3 would be the tangent of 30. Okay? And like I said, if you flip back in your notes and look at our chart, you'll see we're getting the same answers we did yesterday. Okay? Everybody with me? Cosecant. Same thing we've been doing. What am I going to do? Flip what? Sine. Sine was 1/2, so what's the cosecant? 2. Secant of 30. I flip the cosine, which was square root of 3 over 2, so that's going to be 2 over square root of 3. So again, quick and easy way, move your square root of 3 to the top, take the square root off on the bottom. So 2 square root of 3 over 3, and then cotangent of 30. Flip. I can't flip this, but I'm going to flip that one. What is 1 over square root of 3 flipped? Square root of 3. When you go to flipping, make sure you pick a good one to flip. That makes it less work. All right? It's a lot of red up there. Everybody good? Awesome. I'm going to leave it there for a second because I need to erase it before we do 18, or number 8, excuse me. Smile pretty?
I did, but
Good.
I lost my earring. Pretty upset about it.
Sorry.
Oh, your daughter was late for her picture. She was walking in and she was like, keep in mind, they had already finished D through G, and she was walking up. And she said, did they call us? And they were like, yeah, you were like the first group. And she said, I didn't hear it. It was funny.
That doesn't make any sense.
What do you mean?
You said they had already called D through G. My name's Kate.
Yeah, they called. Oh. Alright, well, she was. I don't understand. She was confused.
Everybody good? Back to the math action. All right. Let me erase my triangle here so we can draw a new one. Also going to erase over here. All right. 225. What quadrant is 225 in? Third quadrant. About right there. Okay. What do you think we're going to get for 225?
Same exact thing.
No, but yeah, what's the word I'm looking for? Reference angle. Okay. What's the reference angle for 225? 45. Okay. Remember, I told you how all the big angles we're going to just condense into reference angles. Okay, reference angle is from 0 to 90, always. So you're always going to be working with those angles. So I make a triangle out of this. All right, so reference angle, it's up here on the board. In quadrant 1, it's just the angle. Quadrant 2, you say 180 minus the angle. Quadrant 3, you say the angle minus 180. That's the one we just did. Okay, so 225 minus 180. And then quadrant 4, you do 360 minus the angle. Before you do that, though, you have to get your angle between 0 and 360. Okay? So if it's like 700, you got to subtract 360 until you get it in between there, and then you can find your reference angle. So we're doing 45, 45, 90. We got 1 is my hypotenuse, right? The radius. So we already did this earlier. I know this is going to be square root of 2 over 2, and this will also be square root of 2 over 2. Yeah, remember from earlier when we got those. Say something if you don't. I'll go over again. We just divided 1 by what? Not 2, but square root of 2. We divided 1 by the square root of 2. Okay? All right. One other thing we have to add here. What direction did we go? Backwards. So that needs to be what? Negative. We also went down, so that needs to be what? Negative. So the point we're working with down here, I'm just going to write up here so it's not way down here, is negative square root of 2 over 2 and negative square root of 2 over 2. That's my x and my y. Everybody good? All right. Sine 225. It's y. So what's y? Negative square root of 2 over 2. Cosine of 225. It's x, which is also negative square root of 2 over 2. Tangent of 225 is y over x. If you divided those first two by each other, what do they get? 1. Positive 1. All right? What is 2n? I can't. My bad. Put a O. I put a. There we go. T dot n.
You just made a new one.
Yeah.
What would the opposite of it be?
Co 2in. 2 dot n. Co 2 dot. Co 2n should be. All right. So cosecant of 225. What would that be?
Teachers, at this time, they're asking for students with the last name of Young through P.
I switched those.
You're not even a student, though, are you? You're not
All right. I flip them. Move the square root of 2 to the top. Take the square root off the bottom. So that'll be negative 2 square root of 2 over 2. What happens here? The 2's cancel. So that will just be negative square root of 2. Okay? Secant of 225. If sine and cosine were the same, cosecant and secant are going to be what? the same. So I don't have to do all that work again. I know it's going to be negative square root of 2. And then last but not least, cotangent of 225 degrees will also be 1, because 1 flipped is still 1. Everybody good? Okay.
A good friend.
That is a good friend. Yes, sir. Sure.
I should have got a T today. I really like it. I should have got one today, but it might give me
Is that better, Dalton?
I get paid for it. I'll get one of the
Everybody's good? All right. Okay, you got it?
Yes.
You go back in there and back, Miss Hand? Mr. Hand. All right.
Where are all your friends?
They all skipped and forgot to tell her it was skip day.
Really?
All right.
Oh my gosh, remember last year?
These.
Skip day? It was like that interview day.
I don't know if this is on yours. Is that on yours? Okay. You need to write this down. This is the one you need to memorize. Okay? If you notice, it's the same thing as it was before, but where there was a 1 before, there is now a what? R. Okay? So this works for any circle, not just if the radius is 1. All right? What do you think the R represents, by the way? Radius. All right? Now, I have to give credit to one of my old students. She came up with what I'm about to tell you. As her way, we had some old hippie, caught another hippie tripping on acid for Sokotoa. She came up with something to that effect for this, okay? But you have to say it in kind of surfer dude style to remember. It helps you remember it. I know it's silly, but it does, okay? So, Madison Davison, if you're listening, shout out to you, girl. All right. She said, it's y over r, x over r, y over x. So, here's the little thing she came up with. You rock. Excellent, rock. You excellent. Make sure you say it. You got to say it like, Spicoli off of Fast Times at Ridgemont High or the Bill and Ted. That's the new thing. That's how they you got to kind of say it in their voice, okay? Because it'll help you remember.
You taught us this before.
I have. You did learn this in algebra too, if you had me.
Yeah.
So yes.
I've heard that before.
You rock. Excellent, rock. You excellent. Okay? And then again, the reciprocals, you just switch them. So you don't have to memorize those. You just know to flip. Okay? So you can use this for any size circle. It doesn't have to have a radius of 1. Everybody follow me. Okay? So that's why I would rather you memorize this, because if it does happen to be the unit circle, well, you just know R is what? 1. Okay? So it's not memorizing 2 different things. You just memorize one thing to cover everything. All right? Everybody good? You got it, press?
I got it.
All right. Okay, R? You good? All right. That's cool. Let's try some. We got 2. It says, find the values of the 6 trig functions for angle theta in standard position if a point with the given coordinates lies on its terminal side. So, that's a lot to say. I'm just going to draw this on the first one, because I want y'all to understand it. You don't have to do this. And when I say don't have to do this, I mean you don't have to draw it. Where is 3, 4? What quadrant?
First one.
It's in the first one. So I'm going to come over here, 1, 2, 3, and go up, 1, 2, 3, 4. Draw my point. There is 3, 4. Make my triangle. You always draw it to the origin and straight down or straight up to the x-axis every time. Okay? This right here is theta. That's the angle we're looking for. Does everybody understand how to do that? So go to your point, draw a line from your point to the origin, make it a triangle. That angle right there next to the x-axis is always going to be your theta. And now they want us to find the 6 trig functions. So how far is this 3. How tall is it? 4. We don't have r, the radius, but we can find it because it's a triangle. Now, I want you to understand, do y'all see a circle?
Yes.
I haven't drawn one, but it's there, okay? All
I
right,
didn't see the circle.
here it is. There's your circle.
That's pretty good.
Thank you. All right, there's your circle. It's not going to have to be drawn. So again, like I said earlier, r is h. They are the same thing. The hypotenuse is always your radius. So, what kind of triangle is this? 3, 4, 5. I don't even have to do the Pythagorean theorem. I just know that it's 5. Everybody got me? If the legs are 3 and 4, I know the hypotenuse is going to be 5. So now I get to find all this other stuff. It's real quick. Here's x. Here's y. What is r? 5. And so, the sine of theta is y over r. You rock, right? Cosine of theta, excellent rock. So, you rock, excellent rock, you excellent. Okay? And now you just do this and then flip them. So, what's y? 4, r is 5. So, 4 over 5. X is 3, r is 5, so 3 over 5. Y is 4, x is 3, so tangent is 4 over 3. And then to do the other ones, you just flip those. So that's going to be 5 over 4. Secant of theta is 5 over 3, excuse me. Wrote that wrong. And our cotangent of theta will be 3/4. Okay? Everybody good? All right. Last one we're going to do. All right. I'm not going to draw the picture this time. I just drew it so to make you understand. Some people need the picture. Some people like the triangle better. Because again, if you do the triangle, you can still do opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All of that still works, okay? This is just another way of kind of looking at it, all right? So
for this, all you need to find is r.
All you need to find is r.
And
now,
you can do the Pythagorean.
what is r?
The radius.
It's the radius, but what is it in the triangle?
Hypotenuse.
Which is c.
So you can use that.
So r is just going to be the square root of x squared plus y squared every time. Okay? Every time. So, that's, like I said, I'm not going to draw it this time because I know what r is going to be. Okay? I know r is going to be the square root of negative 6 squared plus 6 squared. That's 36 plus 36 is 72. That will reduce, that'll be 2 and 36, which is 6 and 6. So I get to bring out a 6 square root of 2. Now, I knew that before y'all knew it because I teach math, okay? But if I didn't teach math, I could still have known that. How could I have known that? What kind of triangle am I dealing with here? A right triangle. What kind of right triangle? A 45, 45, 90. How do I know it's 45, 45, 90? Because the legs are what? Equal. Okay? You got me? If it's an isosceles triangle, or if the x and y are equal, you know it's 45, 45, 90. Therefore, you just take the leg and multiply it by the square root of 2. End up being the same way. Okay? It is crazy. Now, do you have to know that to work it? No. It just saves time. Okay? So, we got everything we need. Sine of theta will be r, or y over r, excuse me. So that is 6 over 6 square root of 2. The 6's do what? Cancel, so that's 1 over the square root of 2. You don't want to leave it like that. Just be square root of 2 over 2. The cosine of theta is x over r. Well, that's negative 6 over 6 square root of 2. Don't reinvent the wheel. You just did all this work. They're the same answer, just this one is what? Negative. So it's negative square root of 2 over 2. Tangent of theta. What is tangent? Y over x. So y over x would be 6 over negative 6, which is negative 1. And then you just flip everything. Cosecant, not coso. Cosecant of theta would be, which one do you think I'm going to flip? The middle one, right here. This right here. It's just going to be square root of 2. Secant will just be negative square root of 2. Again, they're the same, it's just one's positive, one's negative. And last but not least, cotangent. If I flip negative 1, what do I get? I still get negative 1. Okay? Any questions? Not bad at all. All right. Thanks for listening. Shout out Madison Davison. You rock. Excellent rock. You excellent. And as always, stay above the line.